Good day everyone. Today we will present our group project, the electric circuit 1 called BEV10303. We are from group 2. These are my group member. First is me, my name is Chakakat, AE230058. Second member is Beji Cheng, AE230053. And the last member is Chupali, AE230073. This our content. Our content include 3 items. First is electric circuit analysis using the simulator, and the second is electric circuit analysis using manual calculation, and the last is discussion.
Now, I will share about the simulation of circuit 1 and 2. This is the question of circuit 1. Now, I will talk about how the circuit 1 to be developed by using PSPICE software. Only 5 steps to be done. First, arrange 2 voltage source of active watt at the upper and the bottom of the circuit. Second, 3 resistors of 20 ohms and 3 resistors of 30 ohms. Assume that R1, R2, R3, R4, R5 and R6. Third, connect the element with the connecting wire. Fourth, put a ground at the bottom of the circuit in order to assume simulation can be operated successfully. Then we can try to run the circuit and the result will be displayed. I0 will be 1.77 ampere and the V0 is 53.33 watt. And this is question 2, is our circuit 2. In this circuit, also only 5 steps. First, we start in our circuit with around 6 ampere independent current source at right hand side, independent voltage source at right hand side, and a current control current source in the middle. Second, we create 3 resistors that in 10 ohm, 20 ohms, 40 ohms. Assume them as R2, R3 and R1. Third, we connect all the elements with connecting wire. After connecting, in step 4, we also put a ground at the bottom of the circuit can make the simulations can be successful. And the last, we try to run the circuit and the result will be displayed. The result is I0 equal to 1.x amperes and the V0 is equal to 80 watt.
For the manual calculation parts for circuit 1, first of all, we will assign mesh currents to the meshes in a clockwise direction. Next, we will label the currents that flow through the loops 1 as I1, I2 for the second loops, and I3 for the third loops. Afterward, we will assign polarity to each of the elements in the circuit based on the mesh current direction. Next, by applying KVL, which is Kirchhoff, applying KVL to each of the meshes. Next, use on laws to express the voltage in terms of mesh currents, and afterward we will solve the resulting 3 simultaneous equations to get the mesh currents. By referring to the circuit given, we can assume I0 as I3. Next, we will solve the simultaneous equation that we get by using Cramer's rule. From the Cramer's rule, the value of the determinant that we get is 81. Delta 1 as we will get 216. Delta 2 will get 216 also, and for delta 3 we will get the value of 144. The value of I1 we can get it by dividing delta 1 with delta determinant. We can find the value of I1 by dividing delta 1 with the value of determinant, and from there we will get 2.67 ampere. For I2, we will divide delta 2 with determinant and we will also get 2.67 ampere. And for I3, we'll divide delta 3 with determinant and we'll get 1.78 ampere. As the value of I0 is the same with I3, so the value of I0 is 1.78 ampere. While for V0, the V0 value is 30 multiplied with I0 and the value of V0 is 53.33 volt. Next, for circuit 2, we will apply nodal analysis to solve the circuits. As we can see, from the circuit, we have assigned I1, I2, and I3 as the branch currents for each of the nodes. For I1, the value is 6 ampere. Next, by applying both nodal analysis and Kirchhoff's current law at node A that we have assigned, the current flow equation is I1 plus I2 equal to I0. In nodal analysis, we can find the unknown current value by using the formula of higher voltage value minus lower voltage value divided by the resistance value within each nodes. By solving this, we will get our first equation, and similarly, by using the same methods, we will get the second equation at node B. Next, the first equation is multiplied by 2 to get equation 3, and from there, we will subtract equation 3 with equation 2 to get the voltage value at node B. So, the voltage at V0 that we get is 150 volt. Next, by substituting back the voltage value at V0 into equation 3, we will get the value for node. We will get the voltage value for node A is 168 volt. The V0 value can be get by subtracting V voltage value at A and voltage value at B. From there, we will get 18 volt. And based on Ohm's law, V equal to IR, the value of I0 we get is 1.8 ampere. Therefore, the value of I0 is 1.8 ampere and the value for V0 is 18 volt.
For the discussion part, we have analysis from the two calculations, which are simulation calculation and manual calculation. This is the circuit 1 in our group project. From the left hand side, it shows the simulation calculation, and the right hand side is our manual calculation. So from the simulation calculation, we only put all the elements in the circuit and run it automatically from the system, then the answer will display out by the system. So the current one we'll get from the simulation calculation is 2.667 ampere, and the current 2 is 2.667 ampere, and the current 3 is 1.778 ampere. Follow the mesh analysis, we know that the current 3 is same as I0, so I0 is equal to 1.778 ampere, and the V0 shown in the simulation is 53.33 volt. For manual calculation, we use mesh analysis, Kirchhoff's voltage law, and Kronemann rule to solve the circuit. From the manual calculation, we get I1 is equal to 2.67 ampere, I2 is 2.67 ampere, and I3 is equal to 1.78 ampere. So from this calculation, we can know that the I3 is equal to the I0. So I0 will be equal to 1.78 ampere, and V0 can be calculated by using formula 30 I0. So the V0 is equal to 53.33 volt. So from these two calculation, we can conclude that the I1 is equal to 2.67 ampere, I2 is equal to 2.67 ampere, and I3 is equal to 1.78 ampere. Then the I0 will be equal to 1.78 ampere, and V0 is equal to 53.33 volt. For the circuit 2, the left hand side is show the simulation calculation, and right hand side is our manual calculation. So from the simulation calculation, it also same with previous circuit, only put all the elements in the circuit and run it automatically from the system, then the answer will display out by the system. So after running the system, it will display out all the current value and voltage value from the simulator. So the I0 get from the simulator is 1.8 ampere, and the V0 just time with resistor is equal to 18 volt. For manual calculation, we use nodal analysis, Kirchhoff's current law, and Ohm's law to solve the current. From the manual calculation, we get I0 is 1.8 ampere, and V0 followed by the Ohm's law, we get 18 volt in the circuit. By these two calculations, we can conclude that the answer by simulator is same with manual calculation. That's all for our presentation. Thank you.